Okay, so carrying on with the recorded lecture regarding significant digits when you make calculations, you're going to need your calculator as well as the notes that we've been working on. So here's the thing, when we are going to apply a mathematical operation to two measurements, we have to indicate in our answer to that mathematical operation the accuracy of our tool. And we're going to do that by looking at significant figures in that measurement. We treat multiplying and dividing differently than we treat adding and subtracting. When we're multiplying and dividing, we're going to count significant figures, like you learned how to do in the last recording. But when we are adding and subtracting, we're simply going to count decimal places. Now, what applies to both adding, subtracting, multiplying, and dividing is that our answer must express our least accurate tool. So we have to use the number that either has the least number of significant digits or the least number of decimal places to determine what our answer, or how many decimal places or significant digits our answer is going to have. So let's do a few together. We can see in the first example, we're going to divide a couple of numbers. So if you put that in your calculator, 11.075 divided by 12.7, your calculator spits out a number which in magnitude is reasonable, but the number of significant digits is way off. So we have, the calculator spits out 0.867519685. We know that we cannot report that many decimal places. That is a total lie about the value of our tool, or the accuracy of our tool. So we're going to count significant figures. With the 0 being captive, that first measurement of mass has, 5 significant digits. Our measurement of volume, 12.7, has 3 significant digits, which means our answer must have 3 significant digits, and here's where we're going to round it. We're going to keep the 8, we're going to keep the 6, and the 7 is going to round up to an 8 because of the 5 that is directly to the right of it. So the correct answer is 0.868, and don't forget the unit, grams per milliliter, which is a unit of density. Now, whenever you're doing mathematics and chemistry, you get 1 point, or with me anyway, you get 1 point for the answer, and you can also lose that 1 point. So, for example, if you reported 0.868 without the unit, you would lose half a point, and you would only earn half of the 1 point for your answer. But if you had your significant digits wrong as well, maybe you pointed 0.86. Now you've lost a point for your unit, a half a point for your unit, and a half a point for your significant digit, so you lost the entire point for your answer. I will always deduct half points for incorrect significant figures and incorrect units. Okay, second example, we have 140 centimeters times 35 centimeters. The calculator gives us 4,900 centimeters times centimeters is centimeters squared, and that's a unit of volume. Without a decimal in our first measurement, the 140 has 2 significant digits because without a decimal, a trailing 0 is insignificant. The 35 centimeters has 2 significant digits, and our answer needs to have 2 significant digits. Now, without a decimal place, the 2 zeros that are expressed in our answer are insignificant, and only the 4 and the 9 are. So that is the correct answer. You cannot put a decimal place on that because then we have 4 significant digits. Now, in the second example, we're adding. So instead of counting significant digits, we're going to count decimal places. 22.0 centimeters has 1 decimal place. 5.28 centimeters has 2 decimal places, and then 5.5 centimeters has 1 decimal place. We're going to add length plus length plus length. The calculator spits out 42.78 unit centimeters. Centimeters plus centimeters plus centimeters is centimeters. But you can see that we have differing tools here. Our first measurement was made with a ruler that only had a mark for every 1 centimeter. The 0 is estimated. Our second ruler was a little bit better. It had a mark for every 1/10 of a centimeter. The 8 is estimated. And our last ruler had a mark for every 1 centimeter as well. So we have to use our weakest tool. And our least accurate tool has a mark for every 1 centimeter, and the tenths place is an estimate. So we're only going to keep the tenths place in our answer. So to report this properly, 42.8 centimeters. I rounded that up because directly to the right of the 7 is a value that is higher than 5. Last example, again, we're adding. So we're going to, when we're adding and subtracting, we're going to count decimal places. This has 0 decimal places, 2, and 1. We can see in our first measurement that should be capital L, liter. This tool only has a mark for every 10 deciliters. That 0 is the estimated digit. So if we add those numbers together in your calculator, you're going to get 2,464.5 deciliters. We can only put our answer to the whole number. We cannot use that decimal place, so we're going to have to stop there, and we're going to round that up, 2,465 deciliters. And that ones place is estimated, the tens place is known. So what I'd like you to do now is pause the video, get out your trusty calculator, and do the U-tries. And then I want you to turn the recording back on and check your work. Okay, checking your work. The first 3 examples, we are either multiplying or dividing, so I counted significant figures, and then I rounded the answer in my calculator to the lowest number of significant digits in the measurement. That first calculation is a unit of density. Grams per liter is generally how we express gas densities instead of grams per centimeter cubed. The second measurement is a measurement of speed, meters per second. The third measurement, that one's tricky. That's a measurement of area, but you get the value 100. And if you just do 100 with no decimal place, that's 1 significant digit because the trailing zeros are insignificant. So then you're like, hey, I'm going to fix it by plunking a decimal place on there. Well, now it has 3 significant digits because the trailing zeros then become significant. So on this one, you have to put it into scientific notation to get the proper number of significant figures. And then in the last one, we are adding. And remember that when we add and subtract, we don't count significant figures, but we count decimal places. So we've got 3, 4, and 3. And again, our answer has to have our smallest number of decimal places at 3 decimal places. Okay then, thanks a lot.